Hi everyone, I'm Brian who posted this video titled Easy Way to Learn Multiplication Table by Pattern Recognition to help children learn multiplication tables easily. In order to do it, I've made a sort of learning board of multiplication table called GuGuPan, which is a shortened word of Gugudan Haksubpan. Gugudan means multiplication table and Haksubpan means learning board in Korean language. GuGuPan will make it easier for children to learn multiplication table quickly and accurately by understanding some types of patterns contained in multiplication table. Actually, I made this GuGuPan about 10 years ago for my children's math education and it proved to be effective and helpful for my children's case. From now on, I'll call multiplication table as Gugudan for convenience. Then, under the subtitle Gugudan Learning Recipe, I'll explain how to learn Gugudan easily and quickly using GuGuPan. The GuGuPan consists of front of GuGuPan and back of GuGuPan, as you can see in the slide. The front of GuGuPan shows the multiplied values from 1 times table to 9 times table in the same color for each time table. And the back of GuGuPan shows only the multiplied values corresponding to the square numbers between 1 times table to 9 times table in the same color and the remaining values in white. If we print out each of these two sides and attach them so that you can see the front and back, you will create a GuGuPan for your children's Gugudan study. For your information, the front of GuGuPan is designed for students in the introductory stage of learning Gugudan for the first time. And the back of the GuGuPan is made for students who are somewhat familiar with the multiplied values from 2 times table to 9 times table through Gugudan learning recipe. After preparing the GuGuPan like this, if you understand the contents of the next 6 pages of the Gugudan learning recipe slide and engrave the contents of each page through repetitive learning, children will master Gugudan naturally. The first chapter of Gugudan learning recipe is 2 and 3 times learning method, and it wouldn't be too much to learn together because it is relatively easy to children. 2 times table is the multiplication value in the area marked by the red dotted line, and 3 times table is the multiplication value in the area marked by the blue dotted line. The numbers of multiplication values of 2 times and 3 times are not very large, so you may let your kids memorize them simply in order to help memorization training. But if you understand the 2 patterns included in 2 times and 3 times multiplication process, you will easily understand not only those 2 pieces of multiplication, but also the rest of the entire multiplication table. The 2 patterns are repeat pattern and symmetric pattern. The repeat pattern of 2 times and 3 times is as follows, as shown in the picture on the right side of the slide. The value of multiplication 6 or more of 2 times and 3 times is equal to the value of multiplication 1 or more of each time plus 10 and 15 respectively. Understanding this makes it easy to know multiplication values above multiplication 6 even if you only memorize up to multiplication 5 without having to memorize from multiplication 1 through multiplication 9. Symmetric pattern means that the multiplication values in the left and right symmetrical positions are the same based on the purple diagonal line connecting the squared number 1 to squared number 9. As you can see in the GuGuPan, 2 times 3 equals 3 times 2 equals 6, 2 times 4 equals 4 times 2 equals 8, and 3 times 6 equals 6 times 3 equals 18, etc. This understanding of the symmetric pattern results in the multiplication values displayed on the picture of the GuGuPan. As such, the symmetric pattern displayed in the GuGuPan might be understood as a Gugudan learning version of the commutative law of multiplication expressed as m times n equals n times m. Next, we will skip 4 times and move on to 5 times learning method. When learning Gugudan, you don't have to learn from 2 times to 9 times in sequence. You just need to learn the easy to learn times first and then fill in the rest. If your kids are accustomed to asking and answering questions about time in daily life, you can say that the 5 times multiplication learning has already been completed. If the minute hand is at 2, it's 10 minutes. If it's at 3, it's 15 minutes. If it's at 4, it's 20 minutes, and so on. So if it's at 9, it's 45 minutes. In this way, it will not be too difficult to run multiplication values of 5 times in the 5 times learning method at all. You can see from the figure on the right side that the repeat pattern learned in the 2 times and 3 times learning methods is extended from 4 times to 9 times multiplication based on the multiplication value of 5 times. Just as the repeat pattern of 2 times and 3 times could be obtained by adding 10 and 15 for multiplications of multiply by 6 or more, respectively. The repeat pattern from 4 times to 9 times can be obtained by adding 20, 25, 30, and so on for multiplication of multiply by 6 or more, as shown in the figure. This repeat pattern can be expressed by the formula including letters m and n as below, which is an example of the distributive law of multiplication for addition. M times parenthesis 5 plus n parenthesis equal m times 5 plus m times n. Next, we will skip 6s, 7s, and 8s times again and move on to 9 times learning method. 9 times is the last 2 times of Gugudan, and children may find it difficult because the multiplication values are greater than the multiplication values of the other times. However, if you only understand the explanations and diagrams on the right side of the slide, you will find it to be the easiest times as much as the second, third, or fifth times. 9 times can be expressed as 9 times n using the letter n. When n changes from 1 to 9, the first digit of the multiplication of 2 digits becomes n minus 1, and the second digit becomes 10 minus n, and the sum of the numbers of the first digit and the second digit is always 9. It may seem difficult to understand with the text and words, but when you see the content organized in the diagram at the right side, it will be intuitively and clearly understood. The multiplication value of 9 times 1 is 9 because the first digit is 1 minus 1, so it becomes 0, and the second digit is 10 minus 1, so it becomes 9, and consequently 9 times 1 becomes 9. Likewise, 9 times 2 is 2 minus 1 in the first digit, so it becomes 1. The second digit is 10 minus 2, so it becomes 8. So the multiplication value of 9 times 2 becomes 18, and 9 times 4 is 4 minus 1 in the first digit, so it becomes 3. The second digit is 10 minus 4, so it becomes 6, so it becomes 36. You may get the multiplication value of 9 times by calculating the first and second digits respectively, but you can also find it more easily and quickly with the following method. If the value of the first digit in 9 times is obtained as n minus 1, as in the previous method, the value of the second digit is always 9 minus the value of the first digit. The first digit of 9 times 8 is 7 by subtracting 1 from 8, and the second digit by subtracting 7 from 9 is 2, so the result is 72, like example 2. This also applies to other numbers, and you can check it right away by comparing the numbers of n in the table with the numbers in the first and second digits. If you understand this pattern, you will know the result immediately and instantly, no matter how many times 9 is multiplied by any value. The remaining number after the previous 3 slides is 12 in the cells marked in red on the completion of Gugudan learning slide. Since the symmetric pattern based on the diagonal also can be applied to these 12 numbers, so the actual remaining number is 6. The remaining 6 multiplication values can be learned relatively easily through the repeated pattern values of 4 times, 6 times, and 8 times from repeat patterns mentioned in the previous 5 times learning method, and this concludes Gugudan learning. Children will not be able to fully understand the contents of the Gugudan learning method, which is implicitly summarized in the previous 4 slides after listening to just one explanation. Therefore, give the quoted GuGuPan to children and let them digest and familiarize themselves with it by looking at it frequently. Gugudan learning through GuGuPan is not based on memorization but based on understanding of each child. It is necessary to understand the differences in the learning ability of each child. There's no need to be impatient. even if your kid seems not to be a fast learner. As shown in the picture of the upper right, if you wait patiently, like waiting for the lights in the cauldron to ripen or waiting for the cherry blossoms in spring, at some point, children will be familiar with the Gugudan, just as the lights is ripe and the cherry blossoms in full bloom. At that point, there will be a significant differences in the ability to learn mathematics that can be called as a quantum jump, and as a result, the GuGuPan will be imprinted on the children's brains, and they will be able to freely enjoy not only multiplication but also the mathematical playground of division, fractions, decimals, equations, and functions, etc., which they will learn sooner or later. With this, the multiplication table learning method using GuGuPan is over, but I will finish it with one additional reinforcement learning. Last chapter is about squared number. The squared number is the number multiplied by itself. Both the front and back sides of the GuGuPan are made to stand out by displaying the number of squares from squared number 1 to squared number 9 in the same purple color. So, by the end of the slide on familiarity with the GuGuPan in the previous chapter, your children will probably remember all the squared numbers from 1 to 81. The reason why the square value is displayed in a different color from the other multiplication values on the GuGuPan is that it will help your kids continuously in the process of learning mathematics if they fully recognize the characteristics and scalability of the square value. Write a small 2 in the upper right corner of the number as written in the lower part of the figure on the left, which displays the square value of the product of the same number, and read number squared. For example, 2 times 2 equals 2 squared becomes 4. 5 times 5 equals 5 squared becomes 25. And 9 times 9 equals 9 squared becomes 81. On the right side of the slide, I wrote 3 examples of expansion of the square. These are also things that we can't help but encounter in the course of learning mathematics. First, the 3 consecutive natural numbers that satisfy the famous Pythagorean theorem concerning the lengths of the 3 sides of a right triangle are 3, 4, and 5. In the figure on the left GuGuPan, the squared value of 3, the squared value of 4, and the squared value of 5 are marked with separate borders. Since there are no cases other than these 3 numbers that the square value of the 3 consecutive natural numbers satisfy the Pythagorean theorem of a squared plus b squared equal c squared. These 3 numbers constantly appear in problems related to right-angled triangles, etc. In addition, the formula of trigonometric functions written under the Pythagorean theorem is also born from the relationship between the squares of the 3 sides of a right triangle, so it will be helpful to look at it early. Next, among equations and functions made from combinations of the letters a, b, c, f, g, etc., unknowns x, y, etc., quadratic equations and quadratic functions, etc., which includes x times x, are also examples of expansion of the squared number. Y equal ax squared plus bx plus c, fx equal ax squared plus bx plus c are common expressions of quadratic equations and quadratic functions. And if the multiplication of the same number or the same characters is called a squared number, then a value multiplied by itself 3 times is called a cube, and a value multiplied by itself 4 times is called the fourth power, etc. Equations and functions involving the cube and fourth powers of the unknowns x or y become cubic equations or quaternary functions, etc. Usually, problem solving of these kind of equations and functions is covered in mathematics courses in middle school and above. This concludes the easy way to learn multiplication table by pattern recognition video. Thank you, everybody.